Hello and welcome back to GCSE Science Simplified. Acids don't just sit there, they react, they change, and if you add the right substance, you can completely cancel them out. Today's question is simple. How do you turn an acid into something neutral? This is Chemistry Core Practical 2, and it's all about tracking how pH changes as we neutralise an acid step by step. Let's start with what pH actually means. Acids contain hydrogen ions, H+ ions. Alkalis contain hydroxide ions, or OH- ions. The more hydrogen ions you have, the lower the pH. The more hydroxide ions you have, the higher the pH. And right in the middle, that's pH 7, and that's neutral. That's the target in this practical. In this investigation, we're reacting hydrochloric acid with either calcium hydroxide or calcium oxide. This is the white powder that you would have added to the acid. As you add the base, the white powder, the hydroxide ions react with hydrogen ions. They combine to form water. This is what neutralisation is. Think of it like cancelling out. The H+ ions, H+ react with the OH- ions to make H₂O. Each addition of more alkali removes more acid until there's none left. Here's the setup. Let's take a fixed volume of dilute hydrochloric acid. Then you add measured amounts of calcium hydroxide or the calcium hydroxide, and after each addition you measure the pH. And this is crucial. You're not just doing it once, you're building a pattern over and over again. There are two main ways to measure pH: using universal indicator, placing it on a white spotting tile and adding a drop of solution using a glass rod, and comparing the change of colour of the universal indicator to a pH chart. Secondly, and more accurately, you could use a pH probe, and this gives you a direct numerical reading. So, at the start, the solution is acidic. We have a low pH. It's red. As you add calcium hydroxide, the pH rises. Then, something important happens. The pH reaches 7, or neutral. This is when it's green. But you don't stop there. You keep adding that base. The solution becomes alkaline. The pH rises above 7, it becomes blue or purple, and this tells you you've gone past neutral. The base is now in excess, or too much. This is where students either gain or lose marks. Why must you stir the mixture? Because the solid base needs to fully react with the acid. No stirring equals an uneven reaction equals unreliable results. Next up, what's the best way to measure the acid? We don't just bung it in a beaker, we use a measuring cylinder. Or even better, a pipette. Why that? Well, it's a more precise volume, which means more reliable results. Additionally, we don't just put spatulas of our white powder in, we need to measure it using a balance. How do you know it's exactly neutral? You're looking for pH 7, but here's the challenge. Universal indicator paper is an approximate reading. The pH probe is better. It's more precise. It has a higher resolution. So, let's think like scientists. There are possible errors: not stirring properly, misreading your colour changes, or inaccuracies with your mass measurements. So, how do we improve all of this? Well, we use a pH probe instead of indicator paper, and we add small amounts of base in and around that neutral point. We can repeat our readings and calculate a mean, discounting anomalous results. And this is exactly the kind of thing examiners want to see you say. Let's lock this in. Acids contain hydrogen ions. Alkalis contain hydroxide ions. Neutralisation happens when they combine to form water. And the pH moves from being acidic, lots of hydrogen ions, to neutral, where they've cancelled out, to an alkaline solution where there are lots of hydroxide ions. Measuring really carefully is what makes your results valid. This isn't just about doing an experiment, it's about understanding how substances change and proving it with evidence. Next time, we'll move on to the next core practical and continue building your scientific skills. Thanks for listening to GCSE Science Simplified.